So in today's lesson, students will be able to understand and use exponential notation. So exponential, right? Just think of exponent. An exponent, just in case you forgot, is like that small number that's on the top right-hand corner to choose an exponent. Or like y to the third power, the 3 is an exponent. The second objective is students will be able to use exponents to write the prime factorization of a number. All right, part A, understand exponential notation. So there's a few vocabulary words we have to go over: a base, an exponent, and a power. So a base is a repeated multiplication of a factor. I'll go over that better in one moment. Exponent represents how many times the base is used, and a power represents the exponent. So let's go ahead and fill this in, and I'll go over what each one really means. So let's just say we have 3 to the second power. The base would be your 3. The bigger number, or let me rephrase that, not the value when I say bigger, but the one that font size looks bigger. This right here, because the font looks much bigger, that is your base. The smaller font is your exponent, and pretty much a power just means an exponent. So if I can say this as 3 squared, or I can say 3 to the second power. So once again, power, exponent go hand in hand. There's really the other two that you really need to know the difference. So if I was going to expand this, what this means is it's the base that I'm repeating. So it's the 3 that I'm going to keep on writing. But how many times do I write out the 3? I write out the exponent time. So in this problem here, I'm writing out 3, the base, 2 times with a multiplication symbol in between. 3 to the second power really means 3 times 3. What it does not mean, right, so I'm writing an equal sign with a little line through it, what it does not mean is 2 3 times. This right here is a big no-no. You do not do this. Once again, it's the base that's repeating, and you're repeating it whatever the exponent number is. So example 1, please listen to me now, because if you listen to me now, you're going to be doing a lot less work later on. I have kids every year. They just solve it. 1.6 to the 6th power, they're solving it, they're doing all this work, and they didn't have to. Please read the directions. Please read the directions. I'm going to say it one more time. Please read the directions. So example 1, identify the base and exponent. All you have to do is tell me which number is the base and which number is the exponent. You do not need to solve. On your quiz, moving forward, I might give you a question just like this. And all you got to do is tell me which one's the base and which one's the exponent. You do not need to solve. So let's do A and B together. So A, 1.2 to the 6th power. Once again, my base is the one with a bigger font. The 1.2 is my base. And the exponent is the number with the smaller font. So in this case, it would be 6. I'm done. See the benefit of knowing how to read the directions correctly? I definitely recommend moving forward, always read the directions. I know your teachers have told you that many years ago, and I'm still telling you right now, always read the directions. Okay, B. Once again, we're identifying the base and the exponent. So notice how the -4 has parentheses. That is huge. With the parentheses, my base is -4. And then the exponent most kids will get right, and that is 5. And we're done. But I'm going to make up a problem right now. So everyone go ahead and on top and write C. And we're going to write -4 to the 5th power. But this time we're going to do it without the parentheses. Same thing. We're going to identify the base. And we're going to identify the exponent. Here, because the -4 does not have the parentheses, only the number attached to the exponent is the base. So in this problem here, letter C, my base is 4 and not -4. My exponent is still 5, so that's fine. It's just that look at the difference in my answer here. With parentheses, you include everything that's inside the parentheses as your base. Without parentheses, you only include the number that is attached to the exponent. You do not include any other numbers or any other symbols. Let this visual help you understand that better. Alright, go ahead and do these two on your own. Pause the video, of course, and then let's move on to example 2. Once again, read the directions. So example 2, write in exponential notation. Tell whether each statement is correct. If it is incorrect, state the reason. In these type of problems, you're hoping it's correct, because then you just write correct and you're done. Unfortunately, right, if it's wrong though, you do need to write why it's wrong. The good news is on the park, right, spelling, grammar, none of that really matters if you can get your ideas across correctly. So please keep that in mind. So we'll look at letter A together. Letter A says 2 times 2 times 2 equals 6 squared. One thing I always recommend is, why don't you solve it yourself first? So just like when you solve equations, you draw a line to the equal sign. Why don't you actually try solving the left side first? So don't even worry about this. How would you write 2 times 2 times 2 as an exponent? Well, my base is the number that's repeating. So in this case, 2 is repeating, so 2 is my base. And there's 3 2s. So my exponent would be 3. Is that number the number they gave us? If yes, then the answer is correct. And if no, they did it incorrectly. Obviously, because they wrote 6 squared, their answer is wrong. So if it's incorrect, you got to state the reason. The reason why they're wrong is because there's a few ways you can write this out. The first way is you can say that the 2 is repeating 3 times, so it should be 2 to the third power, the exact same way that I explained it. Or you can even come up with how they even got their answer. So the way they got their answer most likely, if I had to guess, was they probably did 2 plus 2 plus 2, which would be 6. And then they put a 2 as an exponent just because the 2 was repeating. Either way, both are incorrect. So I would maybe recommend the first way and just write that 2 times 2 times 2 would equal 2 to the third power because 2 is repeating 3 times. Okay, let's do B together. So B, once again, line through the equal sign. Once again, I'll pretend like this is not here for now. Just if you were to expand 23 to the 4th power, how would you do that? Well, that would be 23 4 times. And then see, did they have the same answer? If yes, they're correct. And if no, they're wrong. And in this case, yes, they had the same exact answer as us. So for B, we just have to write, let's write yes or correct, whatever you want to do. And of course for A, it was incorrect. And this is why. You do this on your own, pause it, and then move on. Here you can write right or wrong. You can write correct or incorrect. You can write yes or no. Just please understand, if it's incorrect, if it's wrong, if you write no, one of those three, please explain why. Don't worry about spelling or grammar. Just get your thoughts across. And of course, we'll go over it together if it doesn't make sense. All right, example 3. Once again, read the directions. Write repeated multiplication using exponential notation. You do not need to solve this. You do not need to do 5 times 5 times 5 times 5 and get a number. All you got to do is rewrite each of these numbers in exponential notation. That means writing it as an exponent. So letter A, 5 times 5 times 5 times 5 is 5, right, to the 4th power. Because 5 is repeating, so that acts as my base, and it's repeating 4 times. So 4 will be my exponent. Okay, letter B. Once again, we're just writing it as an exponent. Your base will be negative 3, but you have to put the parentheses in there. If you don't, the whole thing is wrong. And your exponent would be 1, 2, 3, 4, and 5. Once again, your answer would be wrong without the parentheses, so please make sure to put the parentheses. Your answer is negative 3 to the 5th power with parentheses. And then letter C, same thing. It has a parentheses, so you can just use your number sense. It's 1/2 x, but with the parentheses. And there's 1, 2, 3 times. So b to the 3rd power. Go ahead and do these 3 on your own. You can pause it and then move on. Okay, example 4. Expand and evaluate each expression. Now you have to solve. What word means to solve? Evaluate. Yeah, they could use the word solve instead, but they don't. You need to know that. So whenever you see the word evaluate, it means to solve. They also tell you to expand, and I'll go over that again, but know here that you're going to expand first, and then you're going to solve. You have a calculator, so it won't be too hard. The letter A, 2.5 to the 3rd power, means 2.5 3 times. And then with a calculator, we're going to solve that. So you're going to plug in 2.5 times 2.5 times 2.5. And you should get 15.625. Next one. Because it's said to expand, you have to do it this way. But if it didn't say to expand, you could have also done this with your calculator. I want you to know how. So to do an exponent, you're looking for a caret key. The key looks like this. So in your calculator, you would do 2.5. You would find this symbol, little caret, and then you would put 3. 2.5 caret top 3 would tell the calculator to solve 2.5 to the third power. And you would get, if you'd enter, this answer as well. I want you to know that because the next example will help me illustrate better why parentheses matters. So here we have to expand first, right? So because there's parentheses, I'm writing -4 twice. And I'm running it twice because the exponent's 2. And then I'm solving this. -4 times -4 is positive 16. And I'm done. All right, and let's go to letter C now. Okay, we have to expand first. So here it's 2/3 in the parentheses. So once again, if it makes your life easier, just do each one with parentheses. You don't have to, but if that makes it easier, go ahead and do that. So you can just do 2/3 times 2/3 times 2/3 and then times 2/3 times 2/3. And that's how you expand 2/3 to the 5th power. And then I would solve it. And 2/3 to the 5th power, right? You can just, when you multiply fractions, you can just multiply the top and then the bottom. You don't technically need the same denominators, right? Like with adding, subtracting. So it's just going to be 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, over 3 times 3, which is 9, times 3, which is 27, times 3, which is 81, times 3 again, which is 243. And there's your answer. Once again, if you want to use it with the calculator, which is fine, you would do with parentheses, 2/3, and then caret top, and then 5 for the exponent. And you would still get the same answer, which is 32 over 243. All right, do this on your own. Expand and evaluate each expression. Expand is writing it out like a multiplication problem. I showed you how to do that. And then evaluate means to solve. You can do one of two things. You can solve it as the exponent using the caret top, or you can solve it as a multiplication problem based on the work that you did when you expanded. Either one's going to get you the right answer. Just solve it. All right, example 5. Write the prime factorization of each number in exponential notations. Once again, exponential notations means write it with exponents. So we did this in the prior knowledge unit, but we did it without a calculator. Now you're allowed to use a calculator, but it's still good to know your divisibility rules. Once again, we went over 2, 3, and 5. I most likely went over some more rules with other students. If you know any more, try to apply them. But the basic 3 should be 2, 3, and 5. Whenever you don't know what number to use, try using the rules for 2, 3, and 5 and take it from there. So 81, right? So I don't know what number goes into 81. Maybe you do. I don't. So I'm going to use my rules. Rule 2 is the number even? 81 is not even. So 2 doesn't work. I'll jump over 3 and try 5 next. 5 is the next easiest one. 5's rule is if it ends with a 0 or a 5. Unfortunately, 81 does not end with a 5 or a 0. So 5 doesn't work. Rule 3 is a very good rule to use. You have to remember this. In 7th grade we went over it, and again in 8th grade we went over it. Rule 3 is you add up the digits, and if the sum is a multiple of 3, 3 will work. So for example, in 81, it's really 8 plus 1. You see how that says 81, but there's a plus sign in between? 8 plus 1 is 9. Because 3 can go into 9, 3 can go into 81. So I know for a fact 3 is one of the numbers. To get the second number, all you got to do now is do 81 divided by 3, and you get 27. Now some good news. In the original number, in 81, because 2 and 5 did not work, it will not work again even in your new number, like 27. That's an automatic. So the only thing right now that would work still is potentially 3. Let's do the rule again. The rule is 2 plus 7, right? 27 plus in between, which is 9. 3 can go into 9, therefore 3 can go into 27. One number will be that 3, and then the other number will be 27 divided by 3. Please keep in mind that I'm always circling numbers that are prime already. This is something I went over in the prior knowledge unit, but I'll go over again one more time. Circle the numbers that are prime. It's called prime factorization because you only care about the prime numbers. You don't care about the composite numbers, which is 81 and 27 for now. It's also going to be 9, but let's break it down first. So now we'll break down 9. 9, obviously by here, most of you know that 3 times 3 is 9. And you circle the 3's because they're prime. Once again, 9 was composite, so I don't need that either. I only care about the prime numbers. So now I have 1, 2, 3, 4 3's. So my final answer is 3 to the 4th power. Please understand, I will have to take off some points if you write this as your answer. And the reason why is because in the directions they're asking for exponential notations. That means that only this is the correct answer. Do the rest on your own. So that's 1, 2, 3, 4. There are 20 bacteria in a given sample in a laboratory. During the early phase of culture growth, the number of bacteria keeps doubling every hour. How many bacteria are there after 3 hours? So the textbook was nice and they gave you a visual to use. So I'm just going to go off this visual. You have it also in your notes. So in the first hour, once again, it keeps doubling. You need to know what doubling means. It means an operation and a number. Doubling means you're going to multiply. And the number value of doubling is 2. In short, whenever you double something, you're multiplying by 2. So in the first hour, we're multiplying by 2. And that's a nice little visual to have. In the second hour, we're also multiplying by 2 because we're doubling it again. And then in the third hour, we're going to draw an arrow right to that question mark, we're doubling one more time. So how many times did we double? 1, 2, 3. Once again, when you're multiplying the same number, you can write it as an exponent. So right now, doubling 3 times really means 2 to the 3rd power. Once again, 2 is the number that's repeating, and it's repeating 3 times. This is the only other catch. They only have 1 bacteria right here. But we didn't start off with 1. We started off with 20. So it's going to be 20 times 2 to the 3rd power. And then you're going to solve. Here you can use your calculator, and 20 times 2 to the 3rd power is 160. But 160 what, right? Make sure you label. 160 bacteria. Okay, we have one more problem and we're done. Alright, so before I read this problem out loud, please understand that on your quiz or test, I'm always going to give you the formula. So you don't need to memorize it, but you need to know when to use it. So we use this formula whenever we're talking about compounded interest. So I'll first read off the word problem, I'll go over a little bit what compounded interest is, and then we'll solve. Shanna deposits $100 in a bank account that earns 5% interest, compounded yearly. How much will be in her account at the end of 5 years? So what you're doing here is, please understand, money now is better than money later. Like if I told you, do you want $100 now, or do you want $102 10 years from now? Even though $102 is a little bit more money, you gotta wait 10 years for that. You don't want to do that. So a lot of you are gonna say $100 now, because money now is better than money later. So some people give up their money now in order to get their money back later. But when they get their money back later, they don't just want the same amount they gave you, they want a little extra. And that little extra is called interest. So now we're going to see how much is that little extra that they give you. So the formula once again is A equals P parentheses 1 plus R to the nth power. And they created a little legend here. The P stands for principal, but it's the initial amount that you put in. So whenever you see the initial amount that you start off with, always in dollars, that should be your P. Your N is terms, and that's in years, by the way. Whatever the year amount is, that's your enemy, which is terms. So in this case, because it's 5 years, your N is 5. Just please understand, some word problems might trick you. They might tell you like 6 months. I don't want you to write N equals 6, right? Because that's 6 months. You would have to convert the months into years. And for example, 6 months is technically 1/2 year, or 0.5. So your N would be 0.5. So just please understand, your N is always in years. In 8th grade, they tend to give you N in years already, so you don't have to worry about that. But just in case they don't. Alright, so your N is 5. Your P was the dollar amount that you start off with, which is 100. I forgot to write down 100. And then your R. Your R is the percentage, but there's a little catch to this. Your percentage has to be written as a decimal or fraction. So I can tell you right now, this is going to be the hardest part for all of you. So when you first read this word problem again, you'll be like, oh look, 5%. So my R has to be 5. And you'll be incorrect because it's 5%, but we have to convert it either into a decimal or a fraction. I find it easier to convert it to a decimal. Some students might find it easier to convert to a fraction. It doesn't matter. That's why in the prior knowledge, we went over how to convert percents into decimals or fractions. It is up to you. I'll give you one quick way of doing it. The way I personally would do it is, I would convert it into a fraction first, which would be 5% is really 5 over 100. And then I would convert it to a decimal by putting in the calculator and just doing 5 divided by 100. Please understand that you're reading it like a book. So top number in first, bottom number in second. In your calculator, you're doing 5 divided by 100. And you should get 0.05. So technically, my R is 0.05. That's the hardest part. Now all you gotta do is plug it into the formula and take it from there. So I'll move the formula down here. You can rewrite it if you want to. And we're just gonna plug it in. So A is still A. That's going to be our answer technically. A equals. And then instead of P, we're going to plug down the number, or plug in the number that represents P. So in this case, P represented 100. I'm still going to open the parentheses. Remember, especially in this chapter, they're going to trick you about kids thinking that parentheses don't matter for whatever reason. I don't know. Every year I deal with kids just say, oh, I had to put the parentheses in? Yes. There's a reason why they put it in there, so you have to put it in yourself with the calculator. So I'm opening up the parentheses. So now it's 1 plus. Now instead of the R, I'm putting in 0.05. I'm closing the parenthesis. And then I already told you before, in order to put in an exponent, you got to do the caret top. So you have to put that caret top symbol next. And then you put in what n value is, and the n value is 5, right? Now, one thing I said somewhat incorrectly earlier was we're going to solve how much the interest is, and that's not correct because there's that 1 here in the formula. They're already adding back your initial $100. In short, the answer that we're going to get here is your money back plus the interest. So you're getting the total right off the bat, which is nice. So let's go ahead and plug in everything into your calculator. Start from after the equal sign and plug it in exactly the way you see it. So the first thing you're plugging in is 100 in your calculator. Then you're opening up the parentheses. Then you're doing 1 plus 0.05. You're then closing the parenthesis. Please don't forget that. The parentheses do matter. Closing, right? And then you're going to do caret top. And then you're going to put 5. And then you're going to hit enter. And you're going to get a crazy number, which is fine. And you get 127.628.156 and 3. Please understand, whenever it comes to money, which this is money right here. They don't need to tell you this. You have to automatically assume it. You always round money to the nearest cent. So if you're reading the word problem and you read it like 3 or 4 times already, and they don't tell you to round to the nearest dollar, they don't tell you exactly what to do with it, then you automatically round to the nearest cent. So just think about it. How many digits after the decimal represent cents? That's 2 digits, right? Usually, like, a dollar amount would be like $9.87 or $1.13. It's never, $5.147, right? This is never. It's always 2 digits after the decimal. So 127.62. Right now, that's technically your answer, 127.62. However, because you're rounding, you have to go to that last digit here, the 2, and you got to go next door. 5 or more, raise the score. 4 or less, let it rest. Because this 8 is more than 5, we have to round the 2 up to a 3. So my final answer is $127.63.